Good morning, everyone. Thank you so much for joining us today. My name is Pauline Esalu, and I'll be moderating this live webinar. We're super excited to have you here. This is a 4-session webinar series, and this is the first of the 4 sessions. We welcome all feedback and comments to help us improve the future webinars. This is a TensorFlow and Habana session presented by 3 of our team members. We have Mandy Lee from our application engineering organization, and we have Leon Goldsiger and Xiang Liu from our field engineering team. In today's session, we will cover basic steps to migrate your TensorFlow model, options for distributed training, introduce you to techniques to analyze your model and identify potential bottlenecks using SynapseAI Profiler. And we will conclude with a live Q&A session. If you didn't attend our Getting Started with Habana webinar, it is available, and you could watch that on demand. But before we get started, I have a few housekeeping notes. Today's session is being recorded and will be made available for later viewing. If you have any technical issues or questions, please use the chat feature to reach us. It's at the bottom of the screen. During the presentation, you can use the Q&A section to ask any questions from our experts. We have a team of members who are available to answer those questions. They will be responding throughout the sessions, but we will also allocate a few minutes at the end of the presentation for additional questions. Now, I would like to welcome our first presenter, Mandy. Mandy, go ahead and take the presentation.
Thank you, Pauline. Thank you, Pauline. Good morning, everyone. My name is Mandy Lee, and I'm a deep learning software engineer at Habana Labs. So today I'm going to demo how to migrate a public TensorFlow model to Habana Gaudi with very limited code changes. So let's get started. First of all, for our today's demo, we are going to use Habana base army with Habana TensorFlow 2.7 Docker container installed. And if you have any questions regarding how to create a EC2 instance with Habana base army or Habana DL army, please refer to our first webinar. So in my workspace, I already created an EC2 instance with Habana base army, and I'm able to log in from my terminal. Oh, it's not responsive. Oh, okay. Oh, sorry. So I'm able to log in from my terminal. And inside of this EC2 instance, I also upload the Jupyter notebook into this EC2 instance so that I'm going to demo it today. Because this is just a base army, so I have to pull and install the Docker container inside of it. I'm going to use a Docker run command to do the both pulling and running. Because I have pulled the Docker image inside of this EC2 instance before, so the Docker container gets started immediately. And inside of the Docker container, I also map the Jupyter notebook and also its associated fault into this root example directory. The next thing I need to do is I need to pip install the Jupyter notebook so that we can start the Jupyter notebook server inside this Docker container to run our workload. So now the Jupyter notebook has been installed successfully, and I will start the Jupyter notebook. I will copy the Jupyter notebook server's URL together with its token ID and paste into my web browser. By the way, if you are going to access the Jupyter Notebook server from the web browser on another machine, you have to do the port forward. I will kill this port forward command before that I run. Okay, so now the Jupyter Notebook server can be accessed from my web browser. And we can load the EfficientNet Jupyter Notebook into my web browser. And this Jupyter Notebook server is running inside the Docker container on the SSH instance. So today's demo, I'm going to show how to migrate the TensorFlow EfficientNet to Habana Gaudi card with only 2 lines of code changes. Let's check what is in the current directory. So inside of this directory, I'm going to get a clone the TensorFlow model repository with branch 2.7 into this location. From this location's content, we can see the model's repository has been cloned successfully. And next, I will add this model's location to the Python path. And I will pip install all the dependent Python package into this Docker container so that the EfficientNet workload can be run inside this container. After all the dependent Python package has been installed successfully, we will go to the EfficientNet folder. We will first verify that without any code changes, the EfficientNet model can be run on CPU just with all the content directly from the repository. In the TensorFlow model repository, there are only configuration files for GPU and TPU for EfficientNet, but we can override the configurations from the YAML configuration file by using some Python command argument. So in my example, I will take EfficientNet B0 in our demo, and I will override the number of GPUs and turn off the distribution strategy and use the synthetic data for both training and validation. And I will use the training, I will set the training for 600 iterations, and I will skip all the evaluation. Use those parameters to override the existing configurations in this EfficientNet B0 GPU YAML configuration file. So with this Python command, I'm able to run the EfficientNet B0 on CPU without any problem. So this is the screenshot. This is the snapshot of the running result. From this output result, we can see that training EfficientNet B0 on CPU, the throughput is around 40 images per second. After we verified that the EfficientNet B0 can be run on CPU without any code changes, let's make the code changes to enable this model on HPU. So what I will do is that I just copy these 2 lines of code . And then I will go to the training script. In the beginning of the main function, I will paste these 2 lines of code. And then save the file. What these 2 lines of code will load Habana software module in the beginning of training, and will try to acquire a Habana Gaudi device and register the device to TensorFlow framework. This is all you need to do to enable the efficient net on HPU. So let's go back to the Jupyter notebook. With those 2 lines of code changes, by using the exactly same Python command that we use for CPU, we can kick out the training of efficient net on HPU. In the beginning of the output log, you can see some information such as successfully loaded Habana module and loaded Habana as the op library, something like that. So those messages indicate that you are using Habana software stacks to run your workload. Another thing that I want you to notice that in front of the Python command, I also added an environment variable, tf enable bfloat16 conversion equal to 1. With this environment variable, the efficient net will be trained in bfloat16 data type. If we don't have this environment variable, the efficient net will be trained in IP32 data type. So the training had started with 300 iterations. The first several iterations is just a warm-up. And after the first several iterations of warm-up, the performance is getting better and better. Because I only set the train to happen for 600 iterations, now the training of efficient net on HPU has finished successfully. So this is all I want to show today. And I hope from my demo, you can see how fast and easy it is to migrate an existing model to Habana Gaudi. If you have any further questions, please refer to our website, developer.habana.ai. Thank you. And next, Leon is going to show you how to do the distributed training with Habana Gaudi card. Back to you, Leon.
Hi, good morning, everyone. Thank you very much, Mandy. So let me start my screen share. So my name is Leon Goldgeiser. I'm deep learning software engineer at Habana. So the previous presenter, Mandy, has demonstrated how to migrate a workload into Gaudi-based instance on EC2. Running on a single Gaudi processor. Most often, however, we are interested in a scale out, running more on a single HPU, Habana Processor Unit. And in my presentation, I'm going to demonstrate how this can be done. So let me move it here. So distributed training using Habana Gaudi and TensorFlow can be accomplished using 2 different methods. One of them is using Habana implementation of popular Horovod framework. And the second method is using one of the TensorFlow strategies. And this is the Habana implementation of a TensorFlow strategy. So both methods offer approximately identical performance and scaling efficiency. However, there are some differences between these 2 methods. So for the Horovod, the advantages are that no code changes are necessary if the user already using Horovod with GPUs. It's very simple if scaling from a single HPU to multiple HPU. For example, if you're starting from scratch and if you were able to port your model into Habana HPU, as Mandy demonstrated in the previous presentation, and now you would like to scale out, then this is more straightforward. One condition that exists with using Horovod is that Horovod uses Open MPI library. And so this forces you to use this Open MPI library. It has an external dependency. An alternative method is for using TensorFlow strategy. And this is more convenient if you're already using one of the tf.distribute strategies. And HPU strategy is Habana implemented class, which directly replaces TensorFlow multi-worker mirror strategy. The class implementations and methods are all identical. The advantage is that it doesn't require Open MPI. And the only really change that the user needs to do is to replace strategy equals multi-worker mirror strategy with a line which specifies strategy equals to HPU strategy. So all of this is presented in the center of this slide. And both Habana TensorFlow and Habana Hrobot implementation are based on HCCL, which is Habana Collective Communication Library, which in turn also based on Habana SynapseAI compiler. The compiler communicates with Linux kernel driver implemented by Habana, and everything runs on Gaudi-based server. Okay. So whatever method you choose, changes are really minimal and small to implement. And first we start if you want to do the Habana Hrobot. So the only changes which needs to be done is that you need to import from Habana framework TensorFlow import load Habana module. And you execute this command which loads Habana module. Very important that you need to make sure that this command happens before you import Horovod. And after you import Horovod, you need to run Horovod init, and everything else stays the same. So you don't need to make any further changes in your code. If you want to go to, okay, next slide. If you want to use a different method, which is the TensorFlow strategies implementation, then similar to previous method, you need to import Habana module. You execute this command which loads this module. Here I showed that if in old code you use strategy multi-worker mirror strategy, this needs to be replaced with from Habana framework TensorFlow distribute, you import HPU strategy, and you define a strategy of as an HPU strategy. Okay, so now when we define this, I think we are going to minimize the screen and also demonstrate in a live session how this can be accomplished. So we have already started. We have already started 2 SSH instances, and we created the EC2 instance similar as it was discussed with many presentation with Habana-based AMI. We started 2 SSH instances, and in one of these instances I installed and already started Jupyter Notebook. The second, in the second shell, I want to monitor the performance. So Habana offers a shell. Okay. Now this doesn't want to collaborate. Okay. So interesting. The system seems to die. All right. So we're not going. I wanted to run HLSMI. Oh. Are you guys still hearing me? It says software caused connection abort. I'm still on?
We hear you, yes.
All right.
On.
So, but apparently the connection timeout. Let me see if the Jupyter Notebook and whatever I prepared is still there. Okay, so I apologize for this glitch, but let me see if I can restart it with a new connection. Okay, and I go to this, I copy the public address. So first I load, open. Okay. Okay. All right. So Habana has a tool which allows you to monitor the performance. Okay. And it shows how many Gaudis you have on the system. On this particular system, we have 8 Gaudis, and we can run it in the loop, but the best would be if you run watch HL SMI. And we can actually see the performance as we run it. So the example as I'm going to run is so small, then the running will be so fast, then it's not necessary we will see any significant changes here, but it's still helpful to see that this tool is very useful to monitor the performance of the system. So I'm going to move it to the side, and on the left, I'm going to show the execution. All right, so we have 2 examples Horovod and TF strategy. We are going, so this is the no op, everything was installed. As I said, Jupyter, we installed MPI run. We import IP parallel, and then we import TensorFlow. Okay. We load Habana module. We import Horovod. Now we download MNIST database. So the example I'm going to run is MNIST, and even this operation is extremely fast. We create a model for training. So this is what we discussed before. The changes we need to do is first we did before importing Horovod, we actually did Habana framework, load Habana model, and then the load Habana model before we imported Horovod. As I mentioned in my slides, we created model for training. Now we compile and train the model. When I hit this button, for a split second, you might see that some performance power consumption will increase. You see the memory, actually all the data was already preloaded into each Gaudi processor. Previously, before I loaded all of this, the memory consumption was around 512 meg, and currently it's 32 gig each. And so clicking on this one, it will train. Okay, not necessary. So it was so fast that this actually did not even have time to react and demonstrate increase in power consumption. Once we run the training, we can run model evaluate and see what was the achieved accuracy, and we can see that actually it's pretty decent. Okay, also at this output we can see it actually measures the loss function and the achieved accuracy for each Gaudi accelerator. Okay, and once we are done, please remember that we need to close the client and shut down and clean everything. And you can see here, currently all this Gaudi device is occupied and it's used by this process, and the memory is occupied. When I click this one, in some time, the window on the right is going to change into the smaller. It updates every few seconds, and apparently it's still, okay, now it's updated. All right. So this is what we had to demonstrate for the running Horovod. In very similar fashion, this is using HPU strategy. Again, this is all downloaded and it's no op for us. This is also, we need to download certain libraries and set up certain environments for this run. We set up number of HPUs equals 8. We import TensorFlow. Okay. Now we load Habana module. Okay. So here we import MPI. Now in the next created training session, again, this is what we created. This is new. So instead of whatever strategy TensorFlow was using, we load HPU strategy and we define strategy as the HPU strategy. We execute all of this. Okay. Once we define this main training function, we are running the training. Again, you can see how the memory is populated. So essentially, there was a little bit of delay, but again, when we're trying to run, the memory was populated. Again, the MNIST network is so tiny that Gaudi really work in very leisurely mode here, and the training was performed within several seconds. So once we finish the training, you need to remember to client shutdown such that this device can be used for some other task. Okay, so this is actually finishes my presentation, and I'm going to pass my presentation to the next speaker, Chiang, who is going to discuss how you can run Profiler and see the performance.
Okay, thank you, Leon. I'm going to share my screen and start the presentation. So, hello, my name is Chiang, and I'm a software engineer at Habana. So Mandy tells us how to migrate the model, and Leon tells us how to use the Habana to train on multiple server or multiple cards. But what do you want to do if you have something? if you Spotify that your model is running very slow, or something's wrong with your model, now I'm going to tell you how to use Habana Synapse Profiler and integration with the TensorBoard. So first, something about how to set the configuration for the profiler. You can use a command line tool, which is very simple, just hl prof config and with arguments. Or we have the GUI for the same tool, similar tool. So you can open it and load the plugin files and also check the plugins you want to enable and finally do your training. But if you want to profile a specific block of your code, then you can add these 3 simple lines in your source code before and after the block of the code you want to inspect. Then you will get a similar result for your part. And I'm going to show you in our documentation how does the help from the command line tool looks like. So you can specify several arguments here for the command line tool, and also for the individual cards for the network, and also there are more details here for the GUI. So you load the plugins and check them, and also you can reorder the which one to inspect first. So we have more details in the documentation. Please, if you are interested, you can check them here. And then I want to show how to get the files. It's very simple. So just before you run your Habana training, you just enable the environment variable Habana profile to be 1. Or you can set the configuration with more advanced settings using a JSON file. And then you will get a JSON file and you can view them in the our trace viewer, which is Habana Labs trace viewer.Habana AI. You will see something like this. And the profile has very limited effect on the performance. It only has negligible impact on the host and no impact on the device at all. And it may add some effect to the runtime of the prologue and epilogue and the bandwidth. And you can check more details in the same documentation. Then I'm going to show you how to use the profile, how we can load the profile. And with the hltv.habana.ai, it's completely based on the Chrome tracing website. So you can use both, but we recommend to use our version because it has more features. And if you want to load the profile file, you just click the load and select the JSON files you want. These are the profile files I collected for the ResNext, ResNet, and the simple example. And since ResNext is more interesting to have more information to see, so let's load the ResNext. And you can see here we have the host, and all these numbers are the different multi-threading, different threads which was running on the host side. And you can, this is a timeline, so you can see which operation takes how long on during the whole running of the of your training. And you can also see more information for the device side. We can see HL3, which is the fourth card on the Habana server, and some information about the MME, the matrix multiplication engine, and the DMA access, and also the TPC kernel, the 8 TPC kernel. How do they how are they running? How much time each operator takes on the corresponding sections. So to use this trace viewer, you can click the question mark here, so you know to use W and to zoom in, zoom out, and other actions. So for example, if we want to check the usage of the MME0, then we can just click W until you can see the detailed information for the operations along the timeline. And you can also select multiple operations together to see them here with the time sorted, so you know which one is taking the most time, and you might know something is wrong with them. And we also have the trace viewer with more information to see here. And also you can double click an operator to see more information for the analyzation of this node. So it's a tool to help you to diagnose your training profile to see what might be wrong with them. And you might want to inspect the host side, or you might want to inspect the device side. So it depends on your actual application. And then if you have any questions, please send in the chat. And then I'll tell you about how to use the TensorBoard together with the Habana training. So if you are already using TensorBoard for a long time, you don't want to use this extra website, then Habana is still provide the way to do that. So you don't need to do anything. If you if you just want to see the optimization graph. So when you enable your visualization of TensorBoard and use the Habana to train, then this post optimization graph tag will be added for the clustered TensorFlow graph. And if you want to see more information like the pre and the post synapse graphs, then you can use this another environment variable graph visualization. And to see the trace viewer inside the TensorBoard, you still need the Habana profile. So you can see it in the TensorBoard as well. And this section is a bit information for if you want to see the programming debug messages, then you can set the log level here. 0 means the trace messages, and 1 means the debug messages, and 2 means the info messages. So it's the same for the standard levels. After you set the log levels, then it defaultly will write into the log files. And if you want to change the default folder, you can use this environment variable. If you want to see the messages in the console, then you can enable the console to be true to see them inside the terminal console. And now I'm going to show you a live demo for the TensorBoard. So this is a Jupyter notebook similar to Mandy's notebook, and you just need to set the environment variable graph visualization to get the more tags and Habana profile to generate the profile files for this training. And this part is the simple example Python file I'm taking from our Habana model reference GitHub repo. And what was done extra is only this one. I added the logs folder and the callback function for the TensorBoard, so we can generate the logs required for the TensorBoard to inspect. And it will run now very fast and finish the training. And then the files will be generated on the logs folder. So you can see I have tried several times here. And for the profile tab, you might need to install this plugin. It depends on your TensorBoard version. Then we can load the TensorBoard to see it lively. Here it's a bit small, so I'm opening a new window here to see it in the full screen. So we can see, yeah, normally the accuracy and the loss flow. And what's different for the Habana is that we add some tags here. So if you don't enable the graph visualization, you will only see the extra post optimization graph 0 added. So you know the final optimized graph by Habana. And if you want to see more like the pre and the post, that's something you can know what happened by the Habana optimization process. And here you can select the different training times. Then if you want to see the profile as before, then you just click the profile tag and click check the runs you want to see and find the trace viewer here. Then you will see the similar trace viewer here, but you need to note that because of the limitation of the TensorBoard, the HPU is still shown as TPU here, but it's actually the HPU. See, you will also see the information, the trace viewers for both the device and the host, and the similar actions can be done using the WS and other shortkeys. So it's similar actions here. So this is this ends the presentation of the profiler and the TensorBoard. And if you want to further using our Habana DL1 instance, then we encourage you to try it on AWS and to follow the our collaterals from the developer website and also the documentation website. And also, if you want to try some example models, we have the model reference GitHub repo, which has several TensorFlow and PyTorch model already enabled for our Habana Gaudi device. So you can try them on, and if you encounter any problems or you have any questions, you can post them in the Habana developer forum. We will answer them as soon as possible. And we will have more advanced topics and detailed explanation for other Habana related information in the next few seminars. Now I'm heading over to Pauline for the live Q&A. Thank you.
Thank you so much for that great presentation. We'll go ahead and open up the Q&A. I'll go ahead and read off some of the questions that we have, and then we'll have the team answer it. One of them is the usage of the profile any different for distributed training?
Yeah, it should be similar, but we don't recommend that for the distributed training because it the running for all the cards should be similar for each card. So the performance may not be the final profiler result may not be stable. So we recommend to use the profiler for one card instead of the 8 cards or more cards.
Let's see, is it possible to use the profiler to identify IO bottlenecks? I'm interested in finding out IO optimization for host memory and host storage devices. For example, SSD.
Yes, and I think this is what Jiang demonstrated. So it shows the DMA access for the host, and you can see, for example, the data pipeline. If you inspect the profiling information after your training session, you can see that in the beginning certain time is spent by host, and this is the data loading from whatever your devices are into memory, and then propagating this into device memory. So it is very useful.
Perfect. What is the major difference between Horovod and TensorFlow distribute? Which is best for distributed training?
Okay, this is Leon. Let me again answer this. So it is more a matter of choice and personal preferences, and whatever your experience is. We have observed similar performance, so we cannot say one works better than another. If you didn't use anyone, then Horovod seems to be subjectively, by us, it seems to be more easy to start. However, if you're already a user of TensorFlow strategist and you know everything how to use them the best way, then maybe the tf.distribute is the better choice for you. It's a matter of personal choice.
Okay, let's see. If I use AWS Habana DL AMI, do I still need to pull the Docker container?
No, you don't need to pull the Docker container because the DL AMI already have the TensorFlow or PyTorch framework installed.
Perfect. Let's see. Should you run profiler on a single or on multiple Gaudis?
I think this question was already answered. It's start from single one, because for the distributed data, every Gaudi performs its chunk, and the overall profiling information will be similar for all Gaudis. So it's better to make things simple.
Okay. And the Horovod example, the memory consumption once model was loaded into the device was close to 32 gigabytes. Given the data size and the small model used, where does this size come from?
Again, let me answer this. So Gaudi memory contains both data and instructions, and the size for each device is 32 gig. And we try to optimize for the fastest performance, whatever is necessary to be preloaded. The graph is compiled into instructions, the instructions are loaded into memory, and the input-output data is also allocated in this memory. And as the training runs, to hide the latency, certain like new data can be loaded and unloaded from the device memory. In the similar way, a graph, like the next section of the graph, can be precompiled by Synapse compiler and also loaded to memory as Gaudi device is busy with training. So we try to utilize the entire memory to run as fast as possible.
Perfect. Can the 2-line of code change migrate PyTorch models to Habana Gaudi as well?
Migrating PyTorch model to Habana Gaudi will take a little bit more steps. So in our website, developer.habana.ai, we have some example to explain the steps that needed.
All right, thank you for that. I don't see any other questions coming through. There's one generic one that's asking if we will provide the PowerPoint at the end of the session. We actually will not be giving the PowerPoint presentation, but the recording will be made available. After this, I will send out an email and include a link with the recording. All right, there's another one. Following up on the memory consumption size question. Is this a limitation for training large models?
No, the answer is no, negative. So it's still, you can see for small models or for large models, the memory utilization, we try to optimize on the memory utilization, meaning that for a MNIST, we can feed a lot of data and a lot of operators into memory. And essentially, this is why it takes so fast, because there is no any I/O latency or any I/O operation which can slow down the training. For larger models, obviously, it will not be possible, meaning that some part of the graph with some data will be loaded into memory, also trying to occupy the entire 32 gig space. But as we're running with training, and once we process some of the data, it will be uploaded, and instead, at the same time, new data will be loaded there. There is no limitation. There is no limitation on size of a model we can run. It means only smaller part of the model or prefetching will be used.
All right, I think, let's see. Okay, there's another question coming in. Workloads run using Docker products, the MME utilization. Sorry, I'm not sure what that is. Do you guys understand that?
I think
No, I'm not
asking about why we can show the MME utilization when we are using the Docker, because the device is accessible through the Docker, and so it can show everything both for both the device and the host. So it's not only about MME or TPC. We can see everything for the device through the provider.
Perfect. Are there any references of model implementations on Gaudi with pipeline parallelism or model parallelism across devices?
I can answer that question. This is Shri. We are working on these capabilities, and it'll be available later in the upcoming SynapseAI releases. So watch our release notes, and we'll keep you posted.
Thank you for that, Shri. Any other questions? All right, I'll give it a few seconds, see if we get any more. We got a lot of good questions and answers, so thank you for that. All right, I think we might end this a couple minutes early. So just a reminder, you can access Gaudi on Amazon EC2 DL1 instances. And for our on-premise solution, we have partnered with Supermicro. Please visit our website, habana.ai, for more information on that. With that, I want to give a big thank you to our presenters and also thank you for attending this webinar. Our next session is scheduled in 2 weeks on Tuesday, February 8th at 9 a.m. using the same link. So please mark your calendars. In the meantime, please be sure to visit Habana developer site for more resources and questions. If you have any additional questions, you may go to Habana Forum. Have a great rest of your day, and thank you so much for attending. Thank you.
Thank you very much, Pauline. Thank you, attendees.
Bye, guys. Thank you.
Bye-bye.